welcome to 3.5 example B. Here it is. This table shows the temperature of the air outside an airplane at different altitudes. So here's our input altitude, here's our output temperature. Let's just make this one X and make this one Y for what we're going to be talking about for part B. So part A says add 3 columns to the table and record the change in input values, the change in output values, and the corresponding rates of change. So use the table and a recursive routine to write linear equation in intercept form y equals a plus bx, and what are the real world meanings of the values for a and b in your equation. Alright, so let's look right here. So we're going to say, if I'm going from 1,000 to 1,500, how much am I changing in altitude? Well, that would be 500. How much am I changing from 1,500 to 2,200? That's 700. From 22 to 3,000 is 800. From 3,000 to 4,700, that's 1,700, and from 47 to 6,000, that's 1,300. So we're just saying, how much did I go up? All right, so then in the temperature, how much did I go from 7.7 to 4.2? And that would be negative 3.5. 4.2 to negative 0.7, that's going to be negative 4.9, negative 6.3, and negative 0.7 is negative 5.6. Negative 6.3 to negative 18 is going to be negative 11.9, and between these two is negative 9.1. Okay, so then it says rate of change, degrees Celsius per meter. So it means I'm going to take negative 3.5 and divide it by 500, which then gives you negative 0.007. All right, then we do negative 4.9 divided by 700, and we also get negative 0.007. Negative 5.6 divided by 800, surprisingly you get negative 0.007. And then when we divide these, you get negative 0.007. And then when you divide these, you get negative 0.007. So there we go. The rate of change, all these numbers are equivalent. Even though we have different values, I'm taking a smaller number divided by 500, a slightly larger, or I guess a larger negative number divided by 700. This is the largest y value, the largest x value. And so it all ends up being the same. Okay, so there is our table. So now what we're going to do is use the table and a recursive routine to write a linear equation in intercept form, y equals a plus bx. Well, I know this rate is going to give me that b value. It's kind of what we're changing every time, right? Every meter we're going down 0.7 degrees. So we're going to say start somewhere, and we're going to subtract 0.007 every meter. Right? Okay, now the problem is, where do we start? Well, do we start at 1,000? Do we start at 7.7? And the answer is no, because when we always start, we always want to start when x equals 0. That's the time when we start. So it's not just the first number in your table, it's always when x equals 0. So we have to find that number. Alright, so we know that every meter it's going down 0.007. Alright, so if I want to get back to 0, so if I want to go to 0 from 1,000, I need to go down 1,000 meters, right? So that means I need to move 1,000 meters, which means if I do this for a temperature, if I move 1,000 or 0.007 degrees every 1 meter, that means if I move the decimal point over 1, 2, 3, I would move this one 1, 2, 3. So it means I'm really moving down 7 every 1,000 meters, right? So it means I want to go down 7 every time I increase 1,000 meters. So if I go the other way, I want to add 7 for every negative 1,000 meters I go. So it means I want to add 7, which means that would be 14.7 degrees Celsius when we're at 0. This right here is our starting value. Okay, so our starting value is at 14.7, and we subtract 0.007 every meter. Alright, so now we can write our equation. Remember, y is our output, x is our input, so we can say y is going to equal, where do we start at? 14.7 degrees, and we're going to subtract 0.007 times x, where x is each individual meter. Not 1,000 meters, not 500 meters, not anything like that. It's just this per 1 meter. Alright, so there's our equation for part B. And then for part C, it says, what are the real world meanings of the values for A and B in your equation? Well, A, 14.7, 14.7 is the degrees Celsius when the altitude is 0. Alright, and then what is the negative 0.007? Is the change in temperature for every 1 meter increase. Alright, so it changes the temperature by negative 0.007 degrees Celsius for every 1 meter we increase in the altitude. Alright, so starting value is not always just this first number, because we could really pick whatever number we want to start at. I could start here if I wanted to and kind of change some stuff around. So this starting value is always when our x, our input, equals 0. Alright, there you go.